Okay, so here we are for day 2. Multiply and divide monomials. All right, there's a lot to unpack here, but let's remember our essential question as we keep on going through the lesson today. How are multiplication and division of monomials like addition and subtraction? Because addition and subtraction are easy. 1 plus 5, 10 plus 4, 10 minus 2, 5 minus 8. These are simple problems. So we want to see how that's connected to multiplication and division of monomials. All right. When we review, technically you guys should have seen this before in other math classes, but hey, it's my job to make sure you remember. Wherever you are in doubt, expand that question out. Let's take a look at example A. For example, if I expand that out, 5 squared is 5 times 5. Times 5 to the first power is just another 5. All right, so I'm multiplying. So I have 3 5s here, which means my exponent, because I have 3 5s, would be 5 to the third power. Yeah, that wasn't that hard. So we just added those exponents. Now you might say, hey, Mr. Hain, there's no exponent here. That's because when there is no exponent, that exponent is a 1. So let's take another look at example. Example B. All right, so we know we have to add these exponents together. So I just got 3 plus 5. That's easy. I know what 3 plus 5 is. C to the 3 plus 5 is C to the 8th. Yeah. Again, if you need to review why, when in doubt, as this is repeating itself, expand it all the way out. So 3 C's and then 5 C's. How many C's do I have together? C to the 8th. All right, let's get a little bit faster, a little bit more quick hitting. A little bit more complicated too. I've got numbers and I've got variables. So let's multiply those numbers. Negative 3 times 4. It's easy, it's negative 12. All right, let's take a look at multiplying those exponents. That's x squared times x to the 5th. Well, we just add those exponents together, skadoosh. So that means I've got negative 12, and 2 plus 5 is negative 12 times x to the 7th. So multiply those numbers, then multiply the exponents. All right, cool. Well, let's take a look at division. All right, so then when in doubt, always expand it out. So here we have 8 4s in the numerator and 2 4s in the denominator. And what the? I can cancel those out. Yes. And if I can cancel those out, that means how many 4s do I have left? And where are they? They're in the numerator. And I have 6 of them. So skadoosh, 4 to the 6th power. Which means when I am dividing exponents, I just subtract the exponents. 8 minus 2 would have given me 6. As always, when in doubt, expand it out. All right, so let's take a look at E. So I got to subtract these exponents, 9 minus 4. Skapow. I know what 9 minus 4 is. You do too. You can use your fingers for this one. It's n to the 5th. Nothing wrong with using your fingers. I still do it from time to time. Let's take a look at example F. Now, this looks like a lot really complicated. So let's just take this step by step. All right, the 2's. If you worry about the 2's together, the 5 is larger, so that's going to remain, I got to subtract those, that's going to remain in the numerator. Now for the 3's, the 8 is larger, so that remains in the denominator. And for the 5's, the 2 is larger than the 1. Remember, when there is no exponent, just like we saw in example A, that exponent is a 1. All right, cool. So that means here I have 2 to the 5 minus 2, 5 to the 2 minus 1. I just simple subtraction. Here we go. And as we talked about earlier, the 8 is larger and in the denominator, so the 3 is in the denominator. That is 2 to the 3rd times 5 over 3 to the 6th. Sweet. Yes, you could say 8 times 5 over 3 to the 6th, but we're not even getting there. Let's just leave it like this for now. All right, remember, as in always, when in doubt, expand it out. But the rules are fairly straightforward. When I'm multiplying exponents, I add them. And when I subtract the exponents, I am actually dividing. So let's take a look at the power of a power. So these pictures are somewhat confusing. It looks like here, 2 and a 3, they're not adding. It looks like they're multiplying, because that's a multiplication symbol, the dot. And here, in algebra with only letters, m times n. Sweet. So 6 to the 4th to the 5th means I have 5 of these. How many? 5 of those 6 to the 4ths. So if I were to add 4 plus 4 plus 4 plus 4 plus 4, that's like saying 4 times 5. Repeating your addition is exactly what multiplication is. So really, I just have 4 times 5. You know what 4 times 5 is? 4 times 5 is 20. 6 to the 20th power. Sweet. So the power of a power, you multiply those exponents. So for the power of a power, you multiply those exponents. For the power of a power, you must multiply the exponents. That is correct. Yeah. Let's get some practice. All right. If you're doing this at home, or if I'm doing this in the classroom, I'm going to pause the video right now and be back in a second. Kaboom! I'm back. Let's just review answers. If you raise your hand and you got 5 times 2, which is not 5 times 10. 5 times 2, you guys know, should be just 10. This G is wrong on the screen, but it's right on your paper. 4 times 6 is definitely 24. And then we got I, which is confusing, but really it's just a repeating multiplication. So here we have 2 times 3 times 2. And that's 3 to the 12th. Kaboom. Yes, that's an error. That should be 2 to the 10th power. You got to listen and not see the video for that one. All right, cool. Let's take a look at the power of a product. So here in the example, you see they have a number times an exponent. So this is a multiplication problem being raised to the power. And really what that means is, like you see these arrows, I'm going to be distributing the exponent. So 5 times 1 and 5 times 2. No exponent means that the exponent must equal 1. So that's the invisible 1, quote unquote. You can't see me making air quotes, but I am. And so 1 times 5 and 2 times 5, which gives me 3 to the 5th, a to the 10th. Kaboom. I have a calculator. I found out that was 243 times a to the 10th. Awesome. Remember, to find the power of a product, basically you're distributing the power by multiplying the exponents. Now, not the 1 and the 2, which is inside the parentheses, but you're multiplying the exponent outside the parentheses to the exponents inside the parentheses, like distribution, just like when you're distributing with regular old multiplication. Let's take a look at another example. All right, so these you can do. I have faith. Now, just like last time, if you're watching this at home, take a moment to pause the video, and then after the video unpauses, I'm just going to kind of run through the answers. All right. And we're back. Let's take a look at J. Remember, when there is no exponent, the exponent's 1. I'm multiplying. There we go. 8 squared is 64. That's b to the 18th, so it's 64 times b to the 18th. It is not a 6. It is the letter b. All right, sweet. Let's take a look at K. Is that what you got? Because all I did was distribute the exponents by multiplying. I now have a calculator, so 6 to the 4th power is 1296, x to the 20th, y to the 44th. Kaboom. Let's take a look at L. L tries to get weird because it's got this negative. So I have negative 5 times itself 3 times. Yes, that is my dog that you hear in the background. Her name is Emmy. All right, so that is negative 5 times negative 5 times negative 5. And of course, that gives us negative 125. 2 times 3 is w to the 6th. 8 times 3 is z to the 24th. Kapow. Get there. All right, the last one is like a gigantically complicated word problem, but let's just take a look at what it's trying to say here. A magazine offers a special service to its subscribers. If they can square the logo shown on the smartphone right here, they can receive a special offer from the magazine. So if I want to find the area, that means I'm multiplying this. It's a square. That means I can square that number. We just did this, like right over here. We just distributed those exponents. So if I'm squaring, you just distribute those exponents, and yeah, you're right. Kapow. That's what I'm talking about. All right. So if you're in Avid or my classes, you're writing your summary and making sure that your table of contents is updated. If you are viewing this via the internet for a review, awesome. Have fun. You can write a summary too. If you're keeping up with my notes for chapter 1, then you can write your table of contents too. Sweet. All right, until next time, don't let those exponents and powers scare you.